Hello, I'm just running my demo for my speech recognition mini project app for AAVP. Um, Unfortunately, I couldn't successfully implement it. What happened is I did get it up and running about a week before the deadline, and it was producing about a 60 to 70% success rate. Um, So I basically tried to improve it by changing the data around and the way I compared the data, and I didn't. I accidentally overwrote the original one that I was working on instead of actually making a copy and using the copy. So I accidentally wrote over the original, and I couldn't get that one back. So I've been trying to backtrack and get it back, but I haven't managed to do that in time. So sadly, I kind of have to give him whatever I've got and hope to get marked on my implementation. So since I can't really demo anything, I mean, I can still run it. Um, well, I don't see the point, but when I do run it, it basically the graphics of it is just a plain black screen, and it has a record button. But when you hit the R key, the record button turns red, and I use the RMS amplitude to increase the radius of the circle as a sort of onset for when the speaker is speaking to indicate that it's being recorded. And then you release R, and then straight away it will compute and return a word. What happened is now it's basically just returning the same word over and over again. And originally, what it was doing is it was returning the correct word, but occasionally, probably about 2 out of 5 times, well, 2 out of 10 times, I'd say actually, 3 out of 10. 3 out of 10 times it would return the wrong word, but most of the time it was pretty much returning the right word. Um, where I think I basically went wrong is I basically tried to warp the sound to kind of match the right parts with the right parts that are being recorded and matched against. And I think that's where I kind of failed, and I tried to improve that, and then I just kind of ruined the data around the program, not in time to kind of save it. I genuinely thought that I had the backup, but okay, I'm just going to quickly skim through it. So we've got the SARP methods there, just describing roughly what's there. What I did is I basically I have 5 files, and I only use 5 words, and those words are hello, my name is Usman. Um, Originally, and the date is there. I did have it modeled, which took me quite a while to get. I had it modeled for those 5 words spoken 3 times by 5 different speakers. So there were basically about 15 versions of each word, about 75 altogether, and I compute the MFCCs for those. I did that about FFT size over 2. That bin size, I compute the MFCs for that. Now, going on to how so that's basically where it is. So if they're recording, then it would basically take the MFCCs right here, and it will put it into an array, and the originally it has been changed around quite a bit, but originally I did have it so that it did a FFT size over 2 bin size. So that would give me about an average of 1,000 to about 2,500 rows of MFCCs, each row with 13 coefficients. And there were a lot of repetitions, but the good thing about having a huge bin size was that you could kind of tell, even though there were a lot of repetitions, you could tell that there are certain parts, like points in the sound, where it does switch over, which could, which strongly indicates that there's a change in a vowel or a certain word or the pitch or whatever. So I was originally using that, and the way I was computing it, this was for the way when it was working, is I was calculating the average, and I put this method down at the bottom, which was for the last one, which I kind of lost. What this basically does is it's going through it basically gets the length of the array which contains the whole MFCCs. It divides that into 20 parts, and then for each of those parts it computes the average MFCCs. And so let's say I've got about 2,500 rows of 13 coefficients. It would calculate the average by dividing those into 20 parts, and then it would give me basically 20 rows of MFCC per word. And even though it did kind of lose some of the detail in the sound, it did work. And I put a little diagram structure of what it was meant to look like, so you can go through that. And if I go back up, so after the update, it will take the sound, it would pass that down to the array, and then next step, after you let go of R, which is the record button, it would then go on to search data. Now, before it does search data, this is one thing which gets called in the setup method. What it's basically doing is those files that I showed you earlier, each of those files basically contains all the models in there, and it's not just one version of hello. If hello was 20 MFCC rows long, that would basically have 300 in there, 300 rows. That's basically the 15 versions of the word hello, and 20 by 20 parts listed. So that's the same for all these words. And what this method basically does, the install data, like I said, the values aren't really as correct as they should be, because I was trying to get it back to a working way, not exactly the way that I had it before. But what it was basically doing is going through each of the rows and placing no going through each of the files and placing them into a three-dimensional array. And now by three-dimensional, I'm going to have the I is going to be in the previous example would have been 1 to 20, so each of the rows. These would have been 0 to 13 for each of the coefficients, which is J here. And then F would basically be which version it is. So there would be 15, up to 15 over there. That's just a read file method. And then, yeah, this goes on to the search data method. What I basically did to search the data is I would have my array of the spoken word that was spoken into the mic and stored in there from the update method that I showed you guys earlier, right here. So it will compute that, put it into the search data spoken word array, and then you go to search data, and what it's basically doing is it's going through every single set of MFCCs in the data sets for each of the words. So like I would have modeled each of these long MFCC files, I modeled them into 20 MFCCs per each one, and then I would do the same thing for the spoken array, and that was basically modeled into 20 rows of MFCCs, and then we're just basically comparing them against one another until we've finally got a scoring system where, you know, if the difference for hello for that row of 13, or let's say if we did do it for the whole model, then if that's the lowest, then we'll return a score of 1. And then once it's gone through all the data sets, obviously if it was closer to the words hello, then you would get most of you'd obviously get hello as the highest frequency, and then you just basically list that as the word by basically popping it through here, and then the sentence gets printed out each time it passes through this. So every time you do let go of R and it searches the database, then it would return the word. Now, sorry I'm going on for so long. I just thought because it's not running, at least I can give some sort of proper demonstration where obviously I can't show it to you running, but I'm trying to describe to you as it kind of was, and what I was hoping to fix in time, but what I didn't manage to do. Um, Basically, the reason why I pushed it into 20 MFCCs for the first time was because obviously if you can't, like, if you've got one full array of MFCCs going up to 2000 and then another one's only going up to 700 or 500, then you can't just compare the first one to the first one and the second one to the second one, because one could have been spoken for a little bit longer, it could have been spoken a little bit louder, then you'd get more MFCCs if the amplitude is higher. And I just thought that obviously we'd have to do some sort of dynamic time warping from the research that I got. I was originally thinking, okay, I'm going to basically compute the MFCCs, simple as that, and then I'm going to put additional energy coefficients at the end of each row of data. They're called delta or delta delta frequencies that compute the energy of the sound at that point and append it to the end. And then there's all sorts of normalization filters that you can apply to it to normalize for male to female speakers that could also have been applied to each end of each row of MFCCs. So then instead of having 13, I'd have 15, and then the first 13 would be the MFCCs, and I'll have the delta, and then I'll have the energy and the filter. But that's originally what I thought I'd be doing in my head, but I didn't know how long it would take to actually get data for 75 models and model that data into averages and then compare that data successfully. And I think I kind of did jump the gun a bit, get a bit ahead of myself, and that's probably why it didn't work. I wish I did have that file there for you guys. It was like partially working, which was better than it not working at all. So yeah, basically that's why I did the dynamic time warping. It was simply because you have to kind of compare that first section of sound. So the h, if that was in the first, let's say 50 for one of them, and that one was only 500 long, so the first 10% of that one, and then for one that was 2000, the h might go on for 200, which was the first 10% of that 2000. If we were to compare those two together after getting the average, you'd get a more closer match. So that was the reason why I kind of did the whole warping. I didn't do it right. I don't think I did. I think there was a way that I could have done it more effectively, more efficiently, that would have given me a better result. But that's what I tried fixing. That's what I kind of just like completely lost it all now. But yeah, that's pretty much it. This is one of the audio requests. This is the only bit I'd say that's come from the Maximilian feature extraction example. That was just basically for me to get an idea of the where to get the values from and for it to compute it, and then I was planning on maybe using other values from here, like the magnitude or the frequency, the peak frequency or the centroid to append to the end of it, but I didn't manage to actually do that. Yeah, and then just a bunch of keys. Obviously, the way I was planning on for testing for somebody else, because it would have been modeled to my voice. I was planning on basically keeping the keys 1 to the number 5, playing one sample in each. So you'd basically hold R and press one of those samples, and it would basically run it for you. And like I said, there's more detailed descriptions of other methods that I used in the last one. I know I've gone on for ages now, so I'm gonna leave it now, because I know we were only meant to go on for 2 to 5 minutes, but I feel like I kind of had to, because I don't have an actual demo to show you guys, just a walkthrough on the code. So yeah, thank you so much, and hope I get some marks for this.